Good afternoon, everyone, and welcome back to gridXdays 2022, Day 2. We had an awesome afternoon yesterday speaking to some experts about a range of issues from the gas crisis to how we can follow the Nordics to how we can ensure sustainable solutions to all. Today, we are dealing with energy. So yesterday was a little bit more focused on the status quo, sustainability, and those sorts of topics. But today, we want to deal with the challenges that the energy industry is facing, what energy players need to do to adapt to these challenges, and how we can overcome them. So first up, we're talking about a sustainable ramp up in DERs, or decentralized energy resources. Demand for critical minerals for clean energy technologies is set to rise sharply, more than doubling from today's level by 2030, according to the announced pledges scenario in the IEA's World Energy Outlook. The critical minerals that experience the fastest rates of demand growth are silicon and silver for solar PV, rare earth elements for wind turbines, and lithium for batteries. In the net zero emissions scenario of the IEA, lithium sees the fastest rise among the key minerals, with demand surging by 26 times between today and 2050. According to ARENA, the price for lithium grew by fivefold in 2021, and it's set to increase. Continued technology innovation and recycling are vital options to ease strains on critical minerals markets. High reliance on individual countries such as China for critical mineral supplies and for many clean technology supply chains is a risk for the energy transition, but so too are the diversification options that close off the benefits of trade. So how do we deal with these issues? How can we ensure a sustainable ramp up in DERs from production to destruction? That's what we're here to discuss for the next hour. And to do that with me, I will be joined by Eicke Weber, who's the co-chair of the European Solar Manufacturing Council, senior advisor at Apricum, the Clean Tech Advisory, the president of the German Scholars Organization, and a professor of materials science at the University of California, Berkeley. He was also the director of the Fraunhofer Institute for Solar Energy Systems for 10 years. Eicke dedicates his research and professional activities to the rapid transformation of our global energy system, to sustainability, and based on the efficient use of final 100% renewable energy. Eicke, thank you so much for taking the time to join us today.
Oh, big pleasure to be with you today.
Great. And Eicke will be joined by Yun Luo, who is the CEO of ROSI, Return of Silicon. Based on proprietary technology, they provide complete solutions for recycling precious raw materials from water-storing waste and end-of-life solar panels. Yun earned a PhD of nanotechnology material science from the Max Planck Institute of Microstructure Physics. Yun, pleasure to have you here today.
Pleasure too.
Great. And we have Roman Alberti, who has a background in e-mobility, energy consulting, and a Masters of Engineering from the ETH Aachen University. He co-founded Voltfang in 2020. Voltfang requalifies electrical vehicle batteries after their first life in EVs into storage systems, which can store renewable energies in a sustainable way. In this way, the batteries do not need new resources and are more affordable. Roman, welcome to the panel.
Thanks for the invitation. Glad to be here.
Good to hear. And finally, we have Jakob Bitner, who has worked in business development in a range of companies before founding VoltStorage in 2016. He's the CEO of VoltStorage, and their vision is to make renewables available 24/7 with sustainable battery solutions. They use redox flow technology to produce next-generation batteries to achieve the most compatible price and set the highest safety standards for the stored electricity in the market. Jakob, thanks for being here.
Thanks for having me.
Good. Okay, so we've introduced the panelists. Let's dive straight into the discussion. Eicke, supply chain challenges mean that it is becoming harder to source materials and hardware from other countries such as China. Does Europe need energy independence? And should we build up European production?
As a matter of fact, if we talk about the area of photovoltaics, which is the area of my experience, yes, we definitely are in a situation which I think is intolerable. If you just take global numbers, only 0.4% of the global solar cell production is produced in Europe, 0.4%. In the United States, actually, it's only 0.3%. In the tiny country of Vietnam, it's 1.1%. And these are Chinese companies which work in Vietnam. And of course, the main supplier is China. So I really believe if we take the view that our future energy system, which will be, we are going towards the 100% renewable energy system, which will be based mainly on the two pillars, wind and solar, of course, augmented by storage, augmented by smart grids and flexibility management in the grid. Then, of course, we cannot afford that the solar part is 100% relying on imports. I am not in favor of being in any way autonomous, autark or something like that. That is complete nonsense in today's world, but we definitely cannot be 100% dependent. And therefore, I think we urgently need to build up production capacities in solar cells as well as, and I'm sure my colleagues will talk about it, in batteries and the other technologies which are needed for our future energy system. So it's intolerable to be 100% dependent in this very important part of our future energy system. So we don't want to come from a dependency, especially in Germany. We are talking about the Russian gas, which we are not longer getting. And now we face a dependency on Chinese solar cells. This is just not possible. And in addition, I would like to emphasize something very important. In the area of solar cells, we in Europe, and especially we in Germany, we have really done a good job in keeping technology leadership. We have supported our solar cell research institutes. This was the Fraunhofer Institute I had the pleasure to be director of for 10 years. We have other research institutes in Germany as well as in France, the famous CEA Ines Institute and so forth. So we still have technology leadership, but we gave up on the production because we didn't support our industry in the same way as the Chinese, who found that this is a strategic topic and this has to be supported by the state. We only supported to create the market. We supported what we call the feed-in law in the renewable energy law, but we did nothing to support our industry. So support for our industry is needed. And by the way, if I may add this, the Chinese were so smart to support their industry not by direct subsidies, by pouring taxpayers' money in the build-up of the industry. All they did is they provided credit guarantees. You know, I like to say jokingly, if in 2008 you could spell the word photovoltaics correctly in China, you got $1 billion credit guarantee to set up a PV factory, a PV manufacturing. And most of these credit guarantees, 80–90%, were never needed because the companies flourished and they built up these gigantic capacities. They could wipe out the rest of the world market because they had enough invest capital in their back. And this is why we are where we are today. But looking forward, looking at the enormous prospects which we have ahead, again, the numbers from photovoltaics is what I have in mind. Right now, we are very proud that in March of this year, we crossed the line of 1 terawatt, 1,000 gigawatt of installed PV power. And this sounds really amazing and fantastic and all of that. But all our studies, our simulations show that for a world which is close to 100% based on renewables, we need of the order of 30, 50, maybe even 70 terawatts of PV. So going from 1 terawatt to let's say 50 terawatt in the year 2040 is an enormous challenge ahead of us. I like to say all what we have right now in photovoltaic industry worldwide is just an embryo compared to what we will get in the future. Today, we manufacture annually of the order of 200 gigawatts of photovoltaics, but by the end of this decade, we expect the world annual production will be between 1,000 and 3,000 gigawatts. So this big growth is in front of us. There's a great opportunity for us, and I think we definitely have to grab this opportunity in order to build up the energy system, not only for us, but as well for other countries. Countries like the African countries, countries like the GCC, the Saudis and Emirates, they don't like to be dependent on Chinese solar modules as much as we are. And therefore, having from Europe an alternative will be really having a worldwide impact.
Thank you, Eicke. Some really incredible numbers there, and it really shows how far we have to go.
Yes.
So yeah, still a lot to do. Eicke mentioned a lot there about photovoltaic solar cells, which is also your area of expertise. Do you have anything to add to what he just said?
Yeah, actually, thank you very much to Professor Weber. I think together with you and with a lot of colleagues, we have lived this roller coaster of European PV. Even I'm Chinese. I live in Switzerland, and I'm a CEO of French startup companies in the PV module recycling.
Very good.
Yeah, so pretty international. So first, I would like to say the situation today is not a situation of choice. It's not a situation that we were not conscious that it's so important to have production and market on the same continent. When I look back to see at which step we failed, when I say we now here for Europe. So first of all, the industrialization, we missed completely the upscaling. So when we were still in the golden time, we had solar world. Giga was already a huge number. We were calculating when you had to produce gigawatt, the glass plate have to be transported continuously by the train. So giga was already a big number, and we didn't really look at that step seriously to put resources to have this bridge to go upscaling. This we failed completely. So today it's still a challenge. It's still a challenge on the capacity in Europe to go upscaling, and our vision. There are many more visionary people than the people who are able to do this upscaling to gigawatt. So we talk a lot about Meyer Burger. It's a relatively small producer. They're struggling, if I allow to say that. So this is absolutely, we need support to do this break to go upscaling. And the second is, we always say, look, we have technology. But if you look at the industrial scale cell module production efficiency, the efficiency of the modules, the best come from Chinese producers. It's not from us. We might have some institute who run a couple of modules with certain capacity, efficiency, but absolutely we're not at scale. So why don't we learn from Chinese? This is what I think, so globalization, you share the market, share the capacity of production, you can also share the knowledge. We really have to learn how we go upscaling. This is a part I would really like to point out. This is a place we really have to invest.
Yes.
So this is actually to Professor Weber's. So thank you very much. It was really very nice, very insightful points you said. That was your question, right, Keita?
Yeah, perfect. Thank you, Yun. And switching the topic a little bit, Roman, how can we ensure that supply chain challenges don't hamper the rise in renewable energy and storage capacity?
Yeah, first of all, I have totally agree with Eicke and June in the production. We have to put more production into Europe and to get this in the first place. But in the second place, we have to resource or get all the resources actually. And for that, we have two options. The first option is, of course, mining all the resources here. We can do this with a little bit of lithium here in Germany, for example. But I think that's a way which is very, very hard, especially from society, to bring over that we are now mining lithium in our areas here. So for the second step is probably focusing on the resources we already imported into Europe. So especially the European Union is, I think, doing their a pretty good job. For example, we have the waste hierarchy here in Germany or in Europe at its whole. That means we should always prevent everything to get it to the waste. So that's the first step of it. The second step is of reusing it, and the third step is that we should recycle all that stuff. And we are like right into these second and third step. That means recycling and reusing. And especially for batteries, we see it from the automobile manufacturer. They are often just recycling the batteries instead of reusing it. And why they're doing this? Because all the processes are easier for the first step. When you're recycling step, they recycled a lot of batteries or small amounts of batteries before, so they don't have the processes now. And when you're now saying, okay, I want to reuse the batteries, you are opening up a lot of questions. First of all, you need a running business model, so you have to find out solutions over there. And also you're opening up other questions like who's taking care of the warranty and who's in charge of the battery, for example, and who's taking the recycling afterwards. So a lot of questions are coming actually up there, and the automobile manufacturers are just not getting deep into, because you have to put a lot of effort at the beginning into the whole concept, and afterwards you get the benefits running later on, but you have to put effort in there. And we try at Voltfang to give them opportunities to get this way a little bit easier, that we give them solutions for all these questions, to make the reusing easier for them. And second one, what I also think of the European Union is doing quite well. We are just announced, or Europe just announced the recycling quota of lithium. So we have to recycle all the things in the second step. That means in 2030, I guess it's 4% of lithium should be recycled. And in 2035, it's even 10%. So we have to keep the resources here and to reuse all the resources. So in fact, I think we are on the good way, but for example, in the hierarchy of waste, there is the rule, but nobody's following it because nobody is caring about the rule or even knowing about the rule. So we have to get more pushy on there, and the legislation has to be more fines on something like this.
Thanks, Roman. And while we're on the topic of lithium, Jakob, what kind of energy storage alternatives are there to lithium, and how can we kind of close the cycle?
Yes, so there indeed quite some alternatives. But we need to be clear on this. So there's very little alternative to lithium when it comes to mobile applications. So certainly there are discussions about hydrogen and so forth. But if we look at efficiency and how much energy we need to put in and what we get out, then clearly lithium-based technologies are on the forefront of what we have for mobile applications. And this is clearly important, and this is something we need to understand. We need to understand that there's not enough lithium in the world to make the mobile transition happen, as well as the energy transition happen. Eicke said initially, some numbers, he said we will need 50 to 70 terawatt hours of solar production worldwide, right?
Not hours, terawatt power.
Terawatt hours. So yeah.
No hours, terawatt.
Terawatt, yeah, that's what I said. Terawatt, terawatt, yeah, and that's gigantic. That's yes. Gigantic, and this the production of solar is unfortunately it's predictable, but it's not steady. So it just produces at daytime. Then we need to couple it with wind, and we need to leverage this out. So we need a gigantic amount of storage to make renewables available 24/7, and the numbers are as big as the numbers Eicke told us, right? And we will not be able to make this energy transition towards 100% renewables possible with lithium only, and for that we need alternatives. And to give you an example, if we were to power Germany for 24 hours from with electricity from lithium-ion batteries, we'd need the amount of lithium that we produce in 4 years' time globally. So we need to be producing lithium for 4 years just to power Germany for 1 day from lithium batteries. So this gives you an understanding of the scope of the transition that we are facing. And for that, we need alternatives. We need alternatives for stationary applications to provide electricity on a constant level throughout the day, but also throughout the seasons. So, and that's a huge task that we had. And there are a couple of companies addressing this using different materials and metals. And we at VoltStorage, for example, are building regular flow batteries, as you said initially, Greta, based on vanadium for a certain application, but also commercial applications. But what we really need is long duration energy storage for kind of big wind and solar parks. And this can only be done with materials that are abundantly available. In our case, we're using iron and salt, two globally easily accessible and very cheap materials. And with that, we believe we can build batteries, first of all, at scale, with enough materials, without limiting resources to certain countries where we are dependent of. So we can source all of it in Europe or any other part of the world. And we can really scale this up and make it very cheap, because if a metal is scarce, right, eventually also prices will increase. So and we need to have very cheap energy in the future, and this will be only possible with a mix of different technologies and of a mix of different, in particular, storage technologies and materials.
Yeah, absolutely. Thank you, Jakob. We've had an interesting question from the audience, which could kind of divide the four of you, as we've kind of got two from each side here. York has asked, what will be the bigger challenge, to scale power production, so PV and wind, or power storage to provide the necessary flexibility? Anyone want to jump in there?
That's a very, very interesting question, because I really agree with the person who asked the question. Both these areas are enormously challenging for us. I just want to add one element which we did not yet talk about, and this is the element of second life batteries. You see, we are building up a very big automotive sector, electrical mobility. And of course, if you have a battery, which after 3, 4, 5 years has only 80% of its original capacity, it is not longer useful for the car, because the car reduces its range by 20%, and you need the range in order to reach your goal. So you will replace this battery, but you should not recycle it and throw it away. You should use the same battery as a stationary battery, because for a stationary battery that has only 80% of the original capacity, it just means you have to put one more box on your wall or in your system, and then you have again the 100%. So I personally expect a revolution of the cost of electricity storage with the upcoming e-mobility market, because as soon as we get these huge amounts of second life car batteries, this will really change the business models. This will really change the opportunities. And I think this will address part of the resource problems, because really, if you want to equip all these millions of cars worldwide with lithium-ion batteries, this will indeed already take a lot of these resources, and we cannot afford to throw them away after 5 years of driving. We need to put them into a economy. We need to put them to good use in stationary batteries. Of course, I have not yet worked out how the dynamics of it work together. Will we get the second life car batteries quickly enough in order to make a major impact in the buildup of our total renewable energy dominated system? That has to be done by somebody else. But in principle, I think this adds another very important aspect, that the simultaneous buildup of electric mobility, of power from renewable sources and storage can come together. But still, I would like to agree with Jakob that this cannot be all lithium-ion technology. The redox flow technology has this huge advantage that you decouple the amount of stored energy and the power you need. The central unit determines how much power in terms of kilowatt, megawatt you can get, and the tanks where you store the electrolyte determines how many kilowatt hours or megawatt hours you get out of the system. So I think this added flexibility is another very good argument that really in a complex and integrated system, these type of batteries will have as well a very important play.
Yeah,
Thanks,
I totally agree there with you. That's actually what we're doing, we're taking the batteries from the EVs and using them for second life. And I think we have to put this a little bit in perspective between the energy sector and the car mobility sector. Because, for example, we would imagine that Volkswagen would have now a fully electrical fleet. They would produce in 3 days the whole amount of batteries that we are actually selling in the energy market right now in the whole year.
Right.
So it's from perspective ways, the electromobility needs a lot more batteries, and just a certain amount of batteries will be used for the energy transition. And even the small amount, for example, of developing cars and what all falls behind by the production of the electrical cars, that's already a big part which we could use to reuse and to use it for the energy transition. But in general, of course, it's not just one technology. We need a lot of different technologies, so everybody has to build up a part, batteries for short term. Then we also need like hydrogen, and something will be a mix between everything probably in the end.
Absolutely. Jakob, do you have anything to add on the audience question of what will be a bigger challenge in the future?
It's super hard to answer, and as Eicke and Roman said, we need a mix of different technologies, and the question is, how do we create the market for it? How do we create the business model? So we need to work on different aspects, and most important, we need to create the business model. So we have the business model for solar production, wind production, and we need to keep pushing this as fast as possible in the market. And I believe so unfortunately in the past, looking back historically, changes were only adopted when we got to the point where we had to make changes. And therefore, I tend to say that we need to push solar and wind as hard as possible and as fast as possible into the market, creating a bottleneck where we need storage all of a sudden, right? And then politics will react and create a regulation to that. In a perfect world, we'd be doing both simultaneously, but unfortunately we're not living in a perfect world, and therefore we must force the market to adapt to new regulations, to new business models.
Absolutely. Thanks, Jakob. And
I may add some words.
Yeah, go for it.
So this question actually reminds me of a question everybody once asked herself or himself, that is the marriage more important, or I have to establish my career first? These two have to go together. We have no choice. Battery and power supply. So I think the policy support that was a joke, but policy support is very important with all this in the residence area. So I give example of our house. So we install solar, and then we have electric cars. Then we had a fantastic idea. Why don't we use electric cars as the batteries for solar? Then we can avoid the batteries to be installed in the garage. No, it's not allowed. And so this flexibility to be introduced for the sake of the technology, for the sake of the efficiency in the energy sector, which somehow needs to be introduced and to be in a fast track, to be recognized that everybody could really contribute to that. It's a very small example. Then I see, as Professor Weber cited, second life batteries. Actually, second life PV modules is also a big problem. So PV modules, when we talk about when we want to use that for second life, it's not only the performance that counts, it's a security. I don't know if in the battery it had the same problem. So solar module, by definition, is not a super secure system, right? It has a power, has tension that has to be secure. So after 20, 30 years already installed, weathering, how do we guarantee that this module is still secured? There will be no leak. It doesn't take fire. So all these regulations actually not in place. To have these regulations in place, we need to have the basic data. So today, I don't know if you have the basic data, how many batteries do have their certain performance? We don't know. What's the percent? 5, 20, 30? Same like PV modules. We guess 5%. Some people say 20%. We don't know. We don't have standard. We don't have statistics. So someone has to start somewhere. So I would really propose, if there's policymakers, to make a little pilot project to get the basic data, then we can start to talk about how to adjust the policy around this small scale data. Then we can have a bigger data. Then we have more policies, more dedicated to the need, to the situation. So thank you.
Thanks, Jan. And Eicke, kind of going on from that, obviously recycling is important, but in terms of finding the materials that we need as well, how can we ensure that we have enough devices to enable the energy transition?
You mean now resources, the materials which we need in order to realize the production of this terawatts? Is that what you mean?
Exactly, yeah.
I mean, each area is very specific. I can just say from photovoltaics, as long as you talk about silicon-based photovoltaics, we are pretty much on the safe side, because silicon is the second most abundant element on Earth. This is no problem at all. We just go to the beach and collect the sand.
I have to contradict you, Professor Weber. Absolutely. There are a couple of mines that offer quartz in the world, and in Western Europe, there are just none. There are a couple of mines, special mines of quartz, a very dedicated quality of quartz that you can produce silicon. It's not the quartz on the beach. It's not the sand on the beach.
You are absolutely right. That we like to use the natural cleaning that nature has provided for us to make a quartz mountain. Because, the sand on the beach is 80–90% clean. The quartz is 95% clean. So it's much better to take quartz than sand from the beach. But physically, chemically, it's SiO2 and SiO2 components. But in any case, I just wanted to continue. It's the silicon is not the problem. But what is the problem? The other materials we need.
It is the problem. I hold my line. Silicon is the biggest problem for EU PV module manufacturing. Big problem. That we don't manage to produce.
I tend to disagree, but because the point is, if you need more silicon, you simply have to use less pure silicon. As long as you can use the quartz from the pure quartz mountains, that's of course the lowest cost, and this nature has done a lot of cleaning. But if this is no longer in sufficient quantities, we can go down in the grade which we use, and we have to add an additional cleaning step. So no problem.
You can clean the sand on the beach. You don't get PV grade silicon. I guarantee you.
Oh,
you need very specific.
I guarantee
no,
absolutely.
No.
It's just a matter of,
no. Show it. No.
Just take a handful of sand and put it through water, and suddenly you see that there are quartz crystals. So it's the essence of sand, but of course it looks brown because it is dirty.
I don't talk about color. The quality is not there. It's not the transparency that counts. We can talk about that another time. This is something we're struggling.
But of course, there are other materials which we need. We need silver, we need copper, and aluminum, of course. In all together, in the silicon photovoltaics area, I don't see such severe problems. In other areas, because we need to think about the total energy system, we have to think about the rare earth materials for permanent magnets for our wind turbines. And there are quite a few issues where we have to be worried about resources and availability. But generally speaking, if you look at the history of the industrialized world in the last 150 years, as soon as something gets needed, you suddenly find new ways to produce it. I mean, at the end of the day, the last resource is the seawater. If anything gets completely out of scale, then we can go to refine seawater. And in seawater, we find most of the rare materials, but of course, in such small concentrations that it will be much more expensive to get it out of there. Therefore, we start using all our resources which we find underground. So altogether, I would say, yes, there will be challenges for resources, but I don't see any serious problem as long as we need it. And just let me make one very general comment. Our future energy system based on renewable energies will be so much less expensive than what we had up to now. We are talking about solar electricity for 1 cent per kilowatt hour, which will be soon, not yet today, but which will be soon possible in solar-rich regions. Even if it turns out that we, for certain areas of our total energy system, need to make more efforts to go to more remote places to mine the materials and so on, we still can do it, because compared to what we had in the past with nuclear energy, with fossil-fueled energy, we are so much more financially and compatible. So I think, yes, we definitely will have to worry about the resources we need if we want to go from 200 gigawatt per year to 1,000, 2,000, 3,000 gigawatt per year production. That will create challenges. I forgot to mention the challenge of glass, because each module has one, or the more modern modules, even 2 sheets of glass, and this has as well to be provided, and this needs as well investment in huge glass factories. But again, I don't see a fundamental limitation there. It's just a matter of question of how much will it cost, but we can do it. I'm quite sure about that.
Thanks, Eicke. Jon, I just want to give you the chance to explain why you see silicon as such a challenge and how we can overcome that.
How we lost this solar market in Europe, to the result, I just look at the result, is we have very little production. Reason is, as I said, upscaling, why we couldn't do it, cost. We don't manage to catch the cost. We don't manage to have the stability in the production. There's another big challenge in the industrial line. So, of course, you have to think about the technical feasibility and also the cost when you want to produce silicon from high quality quartz or sand. Clearly, if we do 1,000 times purification, we will get silicon from sand, probably. But today, this is not how it's done. So there are a couple of mines in the world that can deliver PV grade or semiconductor grade silicon. So what I just quickly looked at that. So today, if we want to support the European PV production, the core material is silicon. Silicon is the material that transforms light into electricity, that we understand that generates electricity from solar modules. So today, if you want to produce 1 kilo of silicon, you need almost 3 kilo of quartz, so high quality quartz. Then you need 1 to 2 kilo of coal, so charcoal, and also between 2 to 3 kilo of wood. And these 3 things are usually not at the same place. So the most critical one, quartz, we have probably 1 mine in Spain, not the highest quality, 1 in France, then that's it. And the mines in other countries, they're actually, a lot of them owned by Chinese. So we don't really spend a lot to go to the very front end of this value chain to secure these raw materials. This is another piece that probably we can also consider. Then we come to the silver. We know actually the highest value in the PV module is silver. So very often people call the recycling of PV modules is called the silver digging. If we manage to get silver from the mines, so we should be able to get the silver back from PV modules to guarantee somehow a European PV module production. So I just want to add, PV is actually a big consumer worldwide for silver. Last year, there was 13% of worldwide silver that was used in PV, and silver is not a material that we increase our production worldwide yearly by a lot. That means with the 15-20% increase of production PV modules, even we use less silver than before, we need a huge amount of silver, and silver is a material which is always in deficit, always, has never been abundant on the market. So recycling gives temporarily, I would say in the next 10, 20, 30, probably 40, 50 years, a good resource of silver. Then afterwards, the research and development has to follow that we could get new technologies that will not use silver, will not use this kind of very critical, limited raw materials. So this also we need a joint force for all the industries to work together to get a sustainable route for development of renewable energy. So this is 2 cents I would like to add.
Thanks, Jon. Yeah, very interesting to get that perspective. Yeah, and some big challenges ahead, but I think we can do it if we all work together. So we have another question from the audience from Henrietta, which I think I'll initially direct to Jakob. Scaling production and storage is one thing, but we also need to upgrade the grids for a decentralized system. How can we live up to that challenge?
yes, we have very good infrastructure, and we can upgrade it. So if you're speaking about a decentralized energy world, right? Then we have energy production at different spots. Of course, I mean, we need to continue upgrading our grid. That's true, and that's a very German aspect. So speaking of that, we're producing wind in the north, and then we need to put it down south. But we need to think of it from a European perspective, and we are actually living in a European interconnected grid, and we need to be upgrading this grid with batteries. So batteries are probably the most important thing that we can add to this system to upgrade them and make them future-proof. So because then they can balance out frequency, which they already do. Like the frequency market is dominated by storage already, and then but also the production. So we need also a capacity market, not just power. We need a capacity market, how to level this out. So I do not see why there's one thing or the other. So we need to constantly upgrade our grid, yes, but we need to upgrade it with storage in particular, because otherwise the grid is worthless when we do not have a constant production and can provide the power that is needed by customers.
Thanks, Jakob. And another part of that is obviously increasing the lifetime of products and increasing the circularity of the assets that we do have. Roman, how can we do that?
I think we always should establish a system behind the first life. In some parts it's pretty easy when we go, for example, for low technology products. It's enough to have like a platform, for example, like Traxxas or eBay Kleinanzeigen. You need to have a platform where the seller and the buyer both profits from this one. So there we already established it by natural from there. But when it comes more to high-tech devices, for example, when we reuse iPhones and stuff like this, we have platforms which are a little bit more high qualified. For example, refurbishes something because they're coming other challenges, for example, like warranty and stuff like this. So we have to provide like this. And especially for our use case, when it comes to batteries, it's getting even more complicated because it's not enough to sell a battery and to buy a battery. You kind of need to test the battery, and who's testing the battery? It could be the platform as well, but then afterwards you should know where to use which battery, because the battery is not a battery. Sometimes it's coming even from the same production, having the same lifetime, and it's coming it's a little bit different because the production was different, the aging was different. And so it's a pretty simple way to just charge and discharge and see how much rest capacity is in there, but even that is not showing you how long the battery is lasting. And so you need to know with a very advanced test which battery you can use for which use case. For example, when you have a Tesla battery from Norway, which was charging a lot of fast charging cycles, you have to know, should I use it in a use case where we have 4 cycles with high temperature, or we use it for a use case where we have 10 cycles a day. So it totally depends where to use which battery for, and therefore we are kind of in the spot, or we need player in the second life area who know which battery could be used for which use case in general.
Yeah, thanks, Roman. And then from a more PV perspective, Yun, what are some of the technical challenges of recycling some of the components in PVs while maintaining their purity and resale value?
We have actually technical challenges from A to Z, in all aspects. So today, all the running PV recycling sites, they do in principle mechanical shredding, which is, I would say, very courageous. It's a pioneer that we start to recycle. We have to start somewhere, even the best technology. Then we start to look at the purity of the materials. Actually, these materials like silicon, silver, which is extremely small amount in PV, copper, they only have values when they are pure. So there are many companies developing technologies. We really had to jump out from the mechanical or traditional hydrometallurgical treatment to get this pure material out. We need a lot of input of technologies, or obeying the basic physical rules that only these physical rules are really, really something solid, will never change. So we really had to develop all the technology in order to have this pure material out. then the story is not finished. The recycled materials, they have a very special morphology or purity. They are very special characters. To re-inject them to which industry is another big question mark, that how we can make our industry to profit from this special grade of materials. I cite again silicon, which is so essential. So silicon, you have the intermediate grade, metallurgical grade silicon from 99% to 99.9%. Then immediately have a jump for PV grade silicon with 6N, so 99.9999%, which is actually not enough today. Today we'll go to 8N. Recycled silicon is unfortunately doped. Even it's very pure, you don't get 6N. So you're in between. How you want to recondition this silicon back to large-scale industry that the whole industry can profit. It's really a domain that needs research, development, and industrialization. This is what we're pretty much fighting. Of course, there are people who say, yeah, recycle will do purification, by segregation will get them back. It doesn't work. It really doesn't work. Boron is such a badly segregated material. You can segregate 1,000 times, and you get some silicon that could make 18% efficiency, which will never be able to hit the high efficiency solar cells. So this is a part that we really have to, I would say, all the knowledgeable person with experience, we have to work together to do this joint force in order to have a viable and sustainable re-injection of these materials that big scale industry can profit. Only then we will have the economic profit. Thank you.
Thank you, Yun. And while on the topic of obviously using technology to help these recycling processes and to ensure that we're using resources that we have a little bit better, Jakob, can you tell us a little bit more about how technology can complement the resources that we have and kind of optimize the resources?
Well, I believe a lot of aspects have been said. So we need to make use of what we have as good as possible, right? We need to have second life applications for lithium or maybe even for solar. But this is not my my specialty, right? And then we need to recycle those resources. So we need to have a closed loop, a closed cycle, how we're using this material. So we need to be aware of it. So we need to get away from kind of this fossil world where we're just burning our materials. This is a circular world that we're getting into, and we need to think all that we're doing from a holistic point of view, and that's super important. And then, of course, we need to use alternative materials. So we need to have different technologies, and we cannot rely on very certain materials for the energy transition. And that's my main point, and that's what we are doing at VoltStorage. So we're building batteries based on iron and salt, and we have mentioned that we need short duration storage. And the whole question is, do we need what do we have the grid for? But the grid is just distributing the power, but we need to store it. We need to have time shifts from production to consumptions, and we need to build up co-location batteries. We need to build up batteries on knots to ensure that the grid can handle kind of all this demand that it's having. And as said, and we can only do this with a variety of technologies. And we need to also make sure that we use materials that are abundant, and we cannot rely only on very scarce materials. And I think there's no simple answer to this question. So that's my answer to that.
Thanks, Jakob. And when we're talking about circularity, Roman, does that mean that materials won't actually have an end of life? Or if they do, what eventually happens to batteries when they reach the end of life?
Yeah, of course, we always have to try to extend the life as long as possible, and especially what Eicke said, when you have the rest capacity of 80% and trying to reuse it afterwards, I think it's not a good idea to say, okay, we're just using it until 60%, for instance, and then it's getting down really quick and it's just lasting 2 or 3 years. I think that's not a solution of a sustainable way of life. So we have to find solutions to extend these life, and especially with batteries, you can do a few things. You can lower down, for example, the C rate. That means intensity of how you're treating the battery itself. You can get on a good temperature level, but especially we came up actually with a solution which also extended a little bit longer. We call it the double pack approach. That means like Eicke said, you should just bring more batteries to the customer. And so we decided we bring double amount of batteries to the customer. And this one enables us to use the battery in a special window where the aging is very, very less. And you probably know that from your laptop and from your smartphones. You shouldn't charge the battery actually over the last 20-30%, because the most of the aging, it's called lithium plating, is taking part in this area. And so you can't just like get rid of it, or at least like down treat it when you're taking the window and not charging it so high. And that's what we're doing. We're taking double amount of batteries because the prices are actually pretty low of the second life batteries, and therefore we can extend the life over the next 10, even 15 years. So I think that is kind of the solution, find ways to do the reuse as long as possible. And afterwards, of course, the recycling takes place, and we hope that the recycling is getting better and better in the future. So we try to kind of fill the gap in the next 10 years where the recycling gets more and more improvements, and we get more and more materials out there. But of course, like June was saying, it's very hard to get the same quality out of the resources what we are putting into in the first place. So the recycling has to evaluate better and better over the next years. And that's, I think, the solution of trying to reuse it as long as possible, and then trying to get a recycling which is really efficient afterwards.
Mm-hmm. And Eicke, is that the kind of solution that you had in mind when you said bringing batteries to the customers, or did you have other things in mind as well? Can we kind of complement that?
No, I think really this is very, very important that we don't think only about recycling in terms of taking things apart and destroying it, because the same is with solar modules. You know, a solar module might be not longer interesting for a very small area application where the degrading efficiency really is very negative. You could transport the solar module to a place where area is abundant, where you have a lot of space. And then if the solar module has not longer 80%, is not longer 100%, but only 80% of its rated power, it can be still happily used there. So I think this will be all part of the future circular economy, because we really have to face the fact all our resources on Earth are finite. You know, that is quite clear. What Earth has provided us is finite, and therefore we have to do this. Another aspect is, of course, and coming back to Yoon's very valuable comments, is replacing more rare materials with more abundant materials. A good example for the silver issue is we can use copper instead of silver. Copper is not as good as silver. The electric resistivity of silver is lower, but of course you have to then make larger connectors, and you can still solve the technology, of course, as well with copper. And if this doesn't work, we still have aluminum to go for. Aluminum is as well an electric conductor. And so technology can help us to solve these issues of limited resources, materials, but altogether, we really have to face that our future will be circular. Otherwise, we will not have humankind in 200, 500 years on this planet. You know, we have had 150 years of a happy life where we just bountifully exploit what Earth has saved for us for millions, hundreds of millions of years. And this cannot go on like this. Future generations have to live in a circular economy. And of course, I think talking about renewable energy, we should be at the forefront of that circular economy.
Yeah, absolutely. Thanks, Eicke. And obviously, when it comes to circular economy, it's really important for sustainability, for reusing resources. But another element of it is kind of energy security, geopolitics of establishing mines in developing countries and the effect that it has on minority communities and things like that. Jakob, can you tell us a bit about why technology is so important to reduce the impacts on other countries as well?
Yes, of course. I mean, there's so much to it, and I must rephrase your question.
Yeah.
we need to use other technologies and we need to bring down costs. And Eicke said a couple of very important things, right? We do not need to use the best materials available to reach the highest efficiency possible, right? We will be living in a world where we have kind of different grades, right? And we need to have also lower grades solar panels, right? Or even lower grade solar batteries with not the best efficiency possible, but then at a very, very cheap price. And we need to be able to sell this this different kind of grades and products to different customers. And this will be extremely important also for the for countries that are not as rich as we are and can afford kind of this transition to happen out of a kind of wealthy situation, right? So they need to leapfrog what we have done over the last 100 to 150 years. So they need to build up the energy systems based on renewables from scratch and build it around it. So and actually the German feed-in tariff scheme was the best development project Germany has ever done, because that brought down costs of solar panels so dramatically. And we need to be aware of this. So we need to go away from kind of having the best possible solution, and that needs to be applied to everywhere. And that, I think, is a very important mindset. And what we also need to be doing is to reduce dependency and avoid monopolies. So I want to pick up this question from the very beginning, where the solar industry moved away from Europe, and in particular Germany. We had also a solar valley, right, in Germany, and we gave that away for free, basically. So we didn't do anything to protect this industry where we have had the knowledge, the technology, right? We had all the experts, we just gave it away. And we need to avoid it at all costs. We need to support the new champions that are being built in Europe, also supported by taxpayers, right? Supported by European Commission, supported by grants, supported by loans, supported by money invested into these companies. They're growing up, and then we need to avoid that they're being exposed to China dumping prices or simply buying these companies, right? Simply wiping it out from the market by just buying them. And we would do the world a huge favor if we set up our own economy and also protect it, so we can have a counterpart to China. Because China, if they now increase, they can do whatever they want. So we have been speaking about gas and oil dependency, right? Now we have a solar dependency. So and this is something we need to avoid. And if there's let's say a conflict, right, of market forces, this will enable a smooth and global transition. Thank you.
Thanks, Jakob. Did someone want to add something there?
I would like to ask a question, actually. I rarely have this opportunity, especially these two, Professor Weber. Questions to everybody. Do you realistically see how we are going to realize the announced 35 gigawatt production of PV in Europe in the coming years? What's credible route to do that?
Well, I can only report, as I'm heading the European Solar Manufacturing Council, we are really actively pushing forward to re-establish solar production in Europe. I can only tell you that there are, we have already Meyer Burger, of course, as an example. We have Enel at the south of Italy. We thought we will get as well REC, but the attractive United States legislation has driven the investors from REC to not invest in Europe, but to go there. So we now have to really make sure, and we have about, I would 5, 6, 7 projects going on of attempts to establish gigawatt scale PV production in Europe. But of course, this has to happen in the next 2 years. We need as well in the next 2 years very, very strong support policies, because, at the moment, investors say we rather invest in PV manufacturing in the United States because you get 30% of the cost of your modules replaced by the tax legislation. So we have to do something similar in Europe, otherwise this will disappear. But I just want to summarize, yes, efforts are under the way, but we are by far not yet over the hill. You know, we definitely need to push on all fronts. And what I'm especially disappointed that at the moment, Germany has not been at the very forefront of these efforts. Other European countries like Spain are already much more actively there. But I am working hard, and colleagues are working hard, that we get Germany and France to join the other countries so that we realize this is of key strategic importance for Europe. Absolutely.
Absolutely. I think we're all working hard on that. But thank you all so much today for providing some insights and talking about how we can reach circularity in the industry. Very important topic, and I think you all brought some really interesting points to the table. So thanks again for your time. Unfortunately, we've run out of time for today, but hope you guys have a great afternoon, and we'll be back in 2 minutes talking about energy prices.
It's been a pleasure.
Bye.